So we're starting section 10.2, arithmetic sequences and series. And today we're only going to be doing sequences. Tomorrow we'll do part B, which will be covering series. And we are working straight from the book. Let's jump right in. Actually, let's review before even jumping right in. So on your notebooks, everybody please jot down the title 10.2 arithmetic sequences, but let's start by reviewing 10.1, section 10.1. So what was 10.1? That was where we identified arithmetic or geometric sequences. So on 10.1, we learned that sequences are simply a list of numbers, right, that have some type of pattern. Now, arithmetic sequences in particular have a common what? Common difference, right? Okay, so common difference, D. So if you're jotting this down, just to review, has a common difference, D. Okay, and geometric sequences have a common what? Ratio, R. Ratio, R. Simple. All right. So we do have these two sequences right here. And just to review, what does a sub 1 mean? The first number on your list, right? A sub 2, second number. A sub 3, A sub 4, A sub 5, and you keep going. So this sequence right here, this list of numbers, it is infinite, has a dot, dot, dot. But does it have a common difference or a common ratio? Is it arithmetic or is it geometric? Arithmetic. And how do we know it's arithmetic? Because it has a common difference. And what is that common difference? 2. All right. Now, how do you find that common difference? I recommend to take a number and subtract the previous number from it. That's what I recommend. So 13, take away 11. 13, take away 11. That is 2. Or you could do like 11, take away 9. 11, take away 9. That is 2, right? 9, take away 7, right? 9, take away 7. 9, take away 7 is 2. So I recommend picking a number and subtracting the previous one from it, picking a number, subtracting the previous one from it, and make sure that it's common between all terms by picking a number and subtracting the previous one from it. 7 take away 5 is also 2. So there is a common difference. This is arithmetic. So that common difference tells you how to get from one term to the next term. 5 plus the common difference 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. So if I did ask you for, let's say, a sub 7, what does that mean? That means a seventh number on your list. And what would the seventh number on this list be? 17. 17. That's right. Because if you kept adding 2, 15, adding 2, 17. There you go. So this one down here, you're supposed to check and see if it's arithmetic. And if you did go 48, take away 24, that's 24. But 24 take away 12 is not 24. So there is no common difference. Then you should try common ratio. And again, for common ratio, you pick a number and you divide it by the previous number. So 48 divided by 24. And you can put that as a ratio, as a fraction, because a fraction is really a division problem. 48 over 24. 48 over 24 reduces down to 2 over 1 or just 2. 48 divided by 24 is 2. But then again, you could have said 24 divided by 12. 24 divided by 12 is also 2. Or 12 divided by 6. 12 divided by 6 is also 2. So we know that there's a common ratio 2 on this one, which makes it geometric. On the above one, we knew that there was a common difference of 2, which makes it arithmetic. Yay? Okay. So that was a review of yesterday, and it's critically important to understand that stuff for what we're going to be covering today. So let's go back to the book here. And in the book, we are going to jump right in to the key concept. The most important part of today's lesson is this a sub nth rule, okay? And let's actually read through this. It says the nth term of an a sub n, the nth term a sub n of an arithmetic sequence in which the first term is a sub 1. We already know what a sub 1, it's the first term, right? We already know it's the first number on our list. And the common difference, D, we already know what common difference is. You simply pick a number, subtract the one previous from it, and make sure it's in common between all its terms. So if you have your a sub 1 and you have your common difference, then you'll be able to plug in that a sub 1 right here and the common difference right there, and it'll give you this a sub nth rule. And this rule will help you find any number you want on that list. Now, it's going to sound kind of weird right now because it's the first time we're talking about it, but as we go through examples, it'll make more sense. So right now, we have to start memorizing this formula right here. A sub nth rule. A sub n equals a sub 1 plus parenthesis n minus 1, close parenthesis, times common difference d, okay? And this does make sense because in an arithmetic sequence, you have a number, then you add your common difference to it. So on an arithmetic sequence, on any sequence, you start with your first term. So there's a sub 1, and then you're going to add your common difference. But the common difference, it's set up like this on this formula. Parenthesis n minus 1, parenthesis times the common difference d out there, okay? So let's actually go to our notes and let's jot this down. Write down the formula and put the name on it, a sub nth rule for arithmetic sequences. A sub nth rule for arithmetic sequences. Once again, it's a sub n equals, it starts with the first term that it starts with, which is a sub 1. And then plus, you got to memorize parenthesis n minus 1 times common difference d. So we should all know that this a sub 1 is the first number on your list. We should all know that d is the common difference between all your terms of your arithmetic sequence. I want to pause it here, and then I'll continue in a bit. Go ahead and copy that down. So this is it. This is like super important. Make sure that when you memorize this, box it in, I don't know, circle it, highlight it. You got to memorize this, right? This is the a sub nth rule for any arithmetic sequence. Arithmetic is a list of numbers that has a common difference d, and you'll see how valuable this formula is, this a sub nth rule is, okay? Before we even show you how valuable it is, let's understand this. You don't have to copy this down, but understand it at the very least. To write the a sub nth rule, you're going to need the first term, which is a sub 1, and you're going to need the common difference. So if you know this first number of your list and the common difference, you'll be able to come up with your formula. You'll be able to come up with your rule, okay? Now, you don't have to copy that down. Let's just understand that you need this value and you need this value to produce your function machine, to produce your rule, to use the formula. And let's see it in action. So the beauty about textbooks is that they give you your key concept, they give you your notes, and then they give you examples, right? So here's example number 1 from the book. It says, find the 12th term of the arithmetic sequence 9, 16, 23, and 30, okay? And it explains it, but I'm not going to go to the explanation. I want to just go to the actual list. You might as well jot that list down in your notebooks right there. 9, 16, 23, and 30. And on the instructions, it says to find the 12th term, okay? So it's arithmetic for sure. They tell us it's arithmetic, and we'll be able to conclude the common difference just by looking at it and subtracting the previous number from it. They want us to find the 12th term, so they want us to find a sub 12. That's the notation for the 12th term. And we will use the formula that we're trying to memorize, okay? So what is a sub 1, guys? 9. A sub 1 is 9, okay? And how about the common difference? 7, okay? And how do you get that common difference? You take a number, subtract the previous number from it. So 30, take away 23 is 7. I mean, you could verify that the common difference is 7, but they already tell you it's arithmetic, so it's guaranteed that the common difference is 7. You could say 16, take away 9, that's also 7. 23, take away 16, that's also 7. So we know that the common difference is 7. Very important detail, common difference is 7, okay? And we also know, very important detail, a sub 1 is 9. Okay, so let's write down the formula that we are supposed to memorize by the end of this period. So the formula is a sub n equals, and by the way, a sub n is just a name, equals any sequence starts with your first term, a sub 1. Now, arithmetic sequences in particular, to get to the next number, you either add a positive number or add a negative number, but you're going to be adding to get to the next number. So a sub 1 is your first number. To get to the next number, you're going to add, so you have to put a plus right there. And then you got to remember that you're going to be having parentheses, and inside of those parentheses, you have an n minus 1, and on the outside of the parentheses, you have your common difference, d. Okay, so everybody please jot that down again right next to this list. I know you already have it up on your notes, but jot it down again. The more you jot it down, the quicker you will memorize it. And then we're going to plug in our two values that are necessary for this formula, the a sub 1 and the d. So the a sub 1 is 9. That's going to go right here, 9. And the d, common difference 7, is going to go right there. So I have a 7. So what do I have? Also, I have the plus, the parenthesis, the n minus 1, have the equal sign, and I have the name of this guy, which is a sub n. Now, this is a function machine that produces the list, but let's first clean this up. What do I mean by clean this up? You have 9 plus parentheses times 7. Let's actually simplify it. And we must distribute before adding. So let's distribute. We have 7 times n, that's 7n. 7 times negative 1, that's negative 7. And of course, bring down the plus and the 9. So we've distributed the 7. Now we're going to combine like terms. We have 3 terms right here. And out of those 3 terms, I could combine the first one and the last one, giving us what?
2.
Positive 2. So what we really have here is 7n plus 2. And that's your a sub nth rule. And that is what we have so far. So you're probably thinking, okay, what is this? And here's the beauty part of this. This right here is everything with regards to this sequence. This is the machine that produces this sequence. Like, for example, if you want your first number, 9, that would be a sub 1 is your first number, 9. So if you did put a sub 1, that would mean that your n is really a 1, right? Which means that you would put a 1 right here. 7 times 1 is 7. 7 plus 2 is that first number, 9. Pretty crazy, right? If I plug in a 2 for n, if I wanted to find my second term, all I have to do is plug in a 2 into this machine and it'll give me my second term. 7 times 2 is 14. 14 plus 2 is 16, right? If I wanted to find my, let's say, first, second, third, fourth term, what do I have to plug in right here? 4. 7 times 4, 28. What's 28 plus 2? 30. 8. Fourth term is 30. Isn't it crazy, right? This machine produces this list. Not only that, this machine will allow you to find any number on the list. So on this question, they are asking for a sub 12, right? So all I have to do is plug in a 12 for n. So to show my work, a sub 12. That's just the notation. That's the name of what work I'm about to do. A sub 12 is really saying I'm about to plug in 12 into this machine. So here's a machine. 7 times, I'm plugging in 12 plus 2. 7 times 12? 84 plus 2?
86.
Yep. So a sub 12 is 86. So I found my 12th term, 86. Just like that, once you have the machine, right? Now, you might be thinking, well, why the heck do I want to do all this work? I mean, I already know the common difference is 7. I could add 7, add 7, add 7. And I could add 7, add 7, add 7, add 7 until I get to the 12th term, 86. Which, yeah, you could do that. But what if I ask for the 100th term? Where you have to add 7 100 times. Forget that, right? I mean, the 100th term, once you have the a sub nth rule, that's just 702. I already know the 100th term is 702. By plugging in 100, 7 times 100 plus 2 is 702. So this machine is amazing, right? This machine produces the list, and not only that, it'll allow you to find any number on the list. You want the 18th number? Plug in 18. You want the 50th number? Plug in 50. Cool?
You just put in, for example, the 12 as the end from the beginning of the equation.
Could we have plugged in 12 from the beginning? How so?
12, so it'll be 12. 9 plus parentheses, 12 minus 1 parentheses.
I got you. Good question. So could we have plugged in the 12 right from the beginning, right? Where you plugged in a sub 1, plug in a 12 right there, a minus, and then times 7? Yeah, you could, right? But that's going to be doing more math right here. It's a lot easier to just plug in 12 right here than add 2, right? So it's good to, I mean, this is the machine right here, like you mentioned. This is the machine right here, and you could plug in 12 right into that number and then do the math, but it's better to distribute, combine like terms. That way you get your simplified function machine that's really easy to plug in any number n, just multiply it by 7, then add 2 to it, okay? But yeah, you're right. So that was this first example. Let's turn the page in the book, and we have another example right here. So go ahead and jot that down. It says, write the equation for the nth term of each arithmetic sequence. And we have this first one, 5, -13, -31, ... You're going to write this in your notebook. I already wrote this down in my notebook. So, they're telling us that it's arithmetic. I mean, they didn't have to tell us that it's arithmetic. We could have looked at these numbers and said, is there a common difference between these guys, or is there a common ratio between these guys, right? But they do tell us it's arithmetic, so in fact, we do have a common difference. What is that common difference, guys? -18, right? Some people try to subtract 13 and 5. What you got to do is pick a number and subtract the previous number from it. So if you did go -13 minus 5, -13 minus 5, common difference will be -18. Are you with me? So we found the common difference. We know a sub 1 is 5, and those are the only two things that you need to use this formula. What is the formula? Let's jot it down once again. I already know you've written it down twice, but let's write it down again so it'll help you memorize it. The formula is you start a sub n equals the first term, which is a sub 1. You always start your sequence with a sub 1. And an arithmetic sequence, to get from one number to the next number, you add, in this case, you add -18, add -18, add -18. So you always add to get to your next number on an arithmetic sequence. So that's why there's a plus sign right there. And then we have the parenthesis. This is the part we have to memorize. Parenthesis n minus 1 times the common difference d. And we already said that the common difference was -18 on this particular example. Okay. So let's plug in our a sub 1, which is 5, parenthesis n minus 1 times common difference, -18. And I am going to put that in parentheses to help me remember that I'm multiplying here. So we're going to distribute, then combine like terms. Okay, distribute, then combine like terms. So we're going to go -18 times n is -18n. We have -18 times -1, that's +18. Bring down the plus 5 that's in front. And out of those three terms, you could combine the +5 with the +18, giving you +23. So the a sub nth rule, a sub n equals the -18n with the 5 plus 18, which is +23. Are you with me? Now that is the machine that produces this list. Okay, and if you're ever doubting yourself, if you're like, man, I don't know if I did this right. Well, you could plug in the number 1, plug in a 1 right there. -18 times 1 is -18 plus 23, that's 5. Hey, a sub 1, when I plug in a 1, I really do get a 5. If you wanted to, you could plug in a 2 right there. -18 times 2, -36. -36 plus 23, when you figure that out, it's -13. It really does give you the second term. You plug in 3, it'll give you the third term. You could plug in 4, it'll give you the next number, and so on and so on. This is the machine that produces that list. Now, that's all it asked for. Write an equation for the nth term. A sub nth term, this is your machine that produces the list. That's your answer, okay? And of course, you could use this machine to find any number you want. You want the 100th term, all you got to do is plug in 100. That'd be a -180 plus 23 would be -177, I believe. I don't know. No, 67. Anyway, you guys get the point. Now, there's a slightly more challenging type of question. It's down here. Right here, they want you to come up with the a sub nth rule, but what are the two things that you need to write the a sub nth rule?
A sub 1.
A sub 1 and common difference. But we have the common difference, but we don't have a sub 1. We need a sub 1, okay? So in math, whenever they give you some information, you plug in what you know to find out what you don't know, right? If I said x plus y equals 5, and I tell you, hey, x equals 2, what does y equal? 3. How do you know? You plugged in the 2 and you figured it out, right? Okay? So that's exactly what we're going to be doing right here. We want the a sub nth rule. So let's first start by writing down the a sub nth rule for this arithmetic sequence. A sub n equals a sub 1 plus parenthesis n minus 1 times that common difference d. And let's plug in what we know to find out what we don't know. okay? So again, like you guys said, we need the first term, which we don't have. And we need a common difference, which we do have. But they also give us something else. They give us a sub 5 is 19. So this is what I'm going to do. I'm going to plug in the 6 already, because I already know that 6 is the common difference. I'm going to put parentheses. I'm going to put n minus 1. And I don't know a sub 1, so I'm going to leave it a sub 1. Now, the a sub n is really any number on your list, right? And they do give us what number on the list? The 5th number on the list, which happens to be 19. So I'm going to first start by replacing a sub n with a sub 5. A sub 5, okay? Which I already know. What is a sub 5 really? 19. So I am going to put a 19 right here after all. So you're probably thinking, then why the heck did you waste time and put a sub 5 right here? Because I wanted you to visually see that the n got replaced with the 5, which means that this n is really a what? A 5, right? So we need to replace that n with that 5 right there. Are you following me? Okay. And now we're going to solve for that missing value that we need, a sub 1. So we still have the a sub 1 right here. We do have the plus, parenthesis, and then you have 5 take away 1, which is 4, and then the times 6 out here. So doing the math, of course, we're going to multiply 4 times 6. That's 24. That's a positive 24. We have a sub 1 plus 24 equaling 19. I want a sub 1 by itself. So I'm going to subtract 24, giving us our final a sub 1 answer, which is negative 5. So negative 5 equals a sub 1. A sub 1 equals negative 5. Are you with me? So now we did find our a sub 1 value of negative 5, and we already know our common difference d. So in case you didn't, well, first let's do this. Let's continue with this right now, and then we'll go back to alternative methods. All right, we'll go back to alternative methods. So right here we have our a sub nth rule. A sub n equals a sub 1, which we know is 5, plus n minus 1 times that common difference d, which in this case is 6. So I'm going to plug in those values. So I have a sub n equals negative 5 plus parenthesis n minus 1 times the common difference 6. And let's simplify this to make this a nice function machine, a nice rule, by distributing 6 times n, 6n, 6 times negative 1, negative 6, bring down the plus negative 5. And out of those 3 terms, you could combine the negative 5 and the negative 6 to give you negative 11 with a positive 6n right before it. So a sub n equals 6n minus 11. Does everybody agree with that work? Understand that work? Great. Okay, so are there alternative ways to getting the a sub nth rule or to getting the a sub 1 term? Yes. You could have thought of this logically. So if they give you a sub 5, what they're really saying is that they're giving you the 5th number, 1, 2, 3, 4, 5. And that 5th number is 19, right? And the common difference is d, which means that if this is a sub 5 right here, a sub 5, that means that the next number, a sub 6, will be 19 plus 6, which would be 25, right? But what we really need is a sub 1 down here, which would be technically subtracting 6 and subtracting 6 and subtracting 6 till you get to a sub 1. That is the logical way of doing it, but I don't recommend that. Why not? Because
it could be like they give you like an a sub 100.
they could give you an a sub 105, right? And then to get back to a sub 1, that'd be ridiculous, right? So great. That's a great logical way of thinking of it. And that's, I mean, if you understood that, then you really understand what's going on. But it's not the most advantageous way of doing it. The best way of doing it is with algebra, by memorizing the formula, plugging in what you know to find out what you don't know, and then going back and plugging in your a sub 1 and your common difference d to get the actual a sub nth rule. Okay, so that was all done right here on this second example in the book. And of course, if you wanted to, you could read through, and they show you how everything's done. They first start by calculating the common difference, D, by taking negative 13 and subtracting 5 from it, or taking negative 18 and subtract, well, anyways, you understand that. They get the common difference, and then they plug in what you know to find out what you don't know. So they do everything that I just went through in this book, okay? Let's jump to the actual homework for today. We're doing 4 questions only, 20 through 23. But in order for us to get really comfortable at doing this, I want to do 2 more examples. These are straight from example 2 from the notes that we just did. And that's why it says example 2. I am going to do this one where it says write an equation for the a sub nth rule of 13, 19, and 25. Everybody copy that down, please, in your notebooks. Write an equation for the nth term, 13, 19, 25. And once again, whenever they ask you for that a sub nth rule, you got to have that formula memorized. Let's write it down. A sub n, that's the name of the formula. And we're going to begin with our a sub 1 term. You always start your sequence with your first term. And in arithmetic specifically, you end up adding that common difference to get to the next number. So you're going to put a plus sign because that's what you do to get from one number to the next. You add the common difference. But we don't know the common difference yet. We'll find that out in a bit. The formula does read plus parenthesis n minus 1 times that common difference d. So we know our a sub 1 term by looking at the list. That's your first number on your list, 13. And the common difference we could find by simply taking a number and subtracting the previous one from it. So 25 take away 19, or 19 take away 13. We already know it's arithmetic. It is a common difference, which is a common difference what? 6. Okay, so we know a common difference is 6. We know our a sub 1 is 13. So we're going to take that 13, plug it right in there. Take that 6, plug it right in there. We'll have a sub n equals 13 plus parenthesis n minus 1 times that common difference, 6. And of course, this is the machine that works, but let's clean it up. Let's distribute and combine like terms. So 6 times n, 6n, 6 times negative 1, negative 6. Bring down the plus, the 13. Out of those 3 terms, we could combine the first one and the last one, giving us a sub n equals 6n plus 7. Yay? Okay, so we have found the a sub nth rule. That's what they asked for on this question. But more importantly, this rule is the machine that produces this list. So again, if you're like, I don't know if I did this right, maybe I messed up, maybe I didn't do this right. So you could always verify it by plugging in the number 1, which should produce the a sub 1 term, which would be 13. When you do plug in 1 right there, 6 times 1 is 6, plus 7 is 13. Or you could plug in 2 and it should give you 19. Plug in 3, it should give you 25. That way you could feel more comfortable that you actually did this right, that you didn't make any mistakes. So I think that's like the easier type of question, because we also have this other one where, again, they provide you information and you need to take what they give you, plug it in to find out what you don't know. Okay, that's what we do in math. So once again, they want the a sub nth term. Whoops, give me a second. So let's write down the a sub nth rule that we need to memorize. Hopefully you're already memorizing it by now. A sub n equals your first term, a sub 1. And again, on a arithmetic sequence, you add the common difference to get to the next term. So you have your first term, a sub 1, you got to add. And the formula reads n minus 1 times that common difference d on the outside. Okay, so what are the 2 things that we need to write this formula? A sub 1 and common difference. Do we have a sub 1? No, we don't have a sub 1, but we need it. Do we have the common difference? Yes. Yeah, it's negative 4. Okay, so we're going to plug in what we know to find out what we don't know. So we know that the d is negative 4. Put that negative 4 right there. We still have the parentheses n minus 1. And we don't know a sub 1, so we're going to keep it a sub 1. Now, what else do they give us? They give us what? A sub 5, which is technically the fifth number on your list. So you could think about it logically, but I want you to solve it with algebra. They give us the fifth number on our list, and a sub n could be any number on our list, and they give us the fifth number on our list. So I'm going to write a sub 5, okay? But the thing is, we already know what a sub 5 actually is. A sub 5 is really negative 12. So that a sub 5, I'm going to replace it with a negative 12. Now, if you're thinking, well, why the heck did we even bother writing a sub 5 in the first place? Because that's where you could visually see that your n became a 5, and that's what you're actually plugging in right here for n. So in the n, you're going to replace it with the 5. So your new equation reads negative 12 equals, we still don't know a sub 1, but that 5 take away 1 is 4, and we have times negative 4. So 4 times negative 4 is negative 16. You have the plus a sub 1 equaling negative 12. And we are solving for that a sub 1 term that we need. So let's get rid of that minus 16 by adding 16 and adding 16, giving us 4 equals a sub 1. So we just found out that 4 equals a sub 1 equals 4. So now we have the two things that we need to write our a sub nth rule, and we're going to plug in that 4 right in here and plug in the minus 4 right there. Making some space right here, we have a sub n equals 4 plus parenthesis n minus 1 times a common difference, which is negative 4. And we are going to make this nicer by distributing negative 4 times n, negative 4n, negative 4 times negative 1, positive 4. Bring down the plus 4 over here, that positive 4. So we could combine the first term with the last term. 4 plus 4 is 8. So our a sub nth rule here is negative 4n plus 8. Negative 4n plus 8. So there's your a sub nth rule. And if you feel that you might have made a mistake, you could always plug in whatever number you want to see. So we don't even have a list, so we can't really plug in 1. I mean, we could plug in 1 to find out what the first number is, but to verify that we did it right, you could plug in the 5 to see if it actually gives you that fifth number, which is negative 12. So if you do plug in a 5 right there, negative 4 times 5 is negative 20. Negative 20 plus 8 is the negative 12. That is your fifth number on your list. So once you have this, you could actually write your whole list. You could write a sub 1, your a sub 2 by plugging in 1, plugging in 2. You could find your 73rd term if you wanted to by plugging in 73, multiplying, adding 8, and it would give you your 73rd term. When you are finding the 17th number or the 10th number, whatever number you want, we use this notation, a sub 10, to find the 10th number, right? So you could actually plug in that 10 and then the plus 8, right? So that would be negative 32 would be the 10th number on our list if we actually had the list. But once again, a sub 10, that's just the notation for the work that we're about to do right here, that we're plugging in the 10 into the actual a sub nth rule function machine. All right, so I apologize, it's probably one of the longest lessons we've ever done. It was from the book, and all I want you to do right now for the rest of the class is to do these 4 questions, 20 through 23. As you could see, you got the arithmetic sequence, 24, 35, 46, arithmetic sequence, 31, 17, 3. And then you have these other 2 questions, 22 and 23, which I don't give you the list, I give you information, which you plug it in to find out your missing values, and then you could use your a sub nth rule or create your a sub nth rule from there. All right, so let's work. If you have any questions, please raise your hand, I'll help you out or help each other out.